Hello students, good time to all. I am Chandan Kumar Pradhan. Welcome to your YouTube channel Chandan Physics. In this video, we are going to discuss quantum dot. Let's begin. What is quantum dot? Before starting to that of quantum dot, let us look a concept. If we consider a non-structured material have at least one of the dimension in that of range like 1 nanometer to 100 nanometer. In such cases, the structure of material can be understood by using quantum mechanics instead of classical mechanics. Quantum mechanics play a vital role to explain such things that in between these ranges like 1 nanometer to 100 nanometer. So, in nanoscale particles of semiconducting materials, that means cadmium selenide and gallium arsenide are known as quantum dots, and their size so that the quantum effects change the energy level of their electrons. Their optical and fluorescence spectra depend on their dimensions. Their optical and fluorescence spectra depend only upon their dimensions. That means its size play an important role to describe the optical and fluorescence spectra. In simpler terms, their color changes with size, as we discussed. With their dimension means the color also changes according to its size. These have potential applications in new kind of lasers and light emitting diodes. Wide range of applications in lasers and light emitting diodes. The particles can be made to emit or observe specific wavelengths in terms of color of light just by controlling their size. In overall these discussions, quantum dots depend upon the size factor, means there will be no such accordance with the wavelength, frequency and antiparticles, the subatomic particles like electron, proton or like this, but that depend upon the size, that in the range of nanometers. So many wide range of applications that quantum dots play. The examples were quantum dots used in composite solar cells, fluorescent biological levels which are both small size particle and tunable energy levels. The fluorescent nanoparticles that are invisible until lit up by ultraviolet light, and they can be made to exhibit a range of colors depending on their compositions. Again, another applications in medical, to detect cancer, to detect the disease cancer, physicians means doctor can design quantum dots that bind to sequence of DNA that are associated with the disease. When quantum dots are stimulated with light, they emit their unique barcodes or labels, making the critical cancer associated DNA sequence level. So, in medical field, quantum dots is used to detect that of DNA sequence analysis. Quantum dots is used in body eliminating the need of biopsy. Biopsy in the sense to extract some tissues from a living body to analyze various body effects or various medical effect of that organism is known as biopsy. Quantum dots also play an important role in case of biopsy. Now, let me prefer how exactly that quantum dots helped. Let us proceed towards that mathematical expression. Neglecting the periodic potential existing in solids. In solids there are the existence of periodic potential, we have to neglect that periodic potential. We can imagine 0 dimensional solids. We consider 0 dimensional solid, 0D solid, in which electron is confined in 3D potential box. In 0 dimensional solid, electron is confined in 3D potential box. In 3D potential box, electron is confined. Electron is confined. With extremely small length. In 0 dimensional solid, electron is confined in that of extremely small length, that is less than 1000 nanometer. Breadth and height of 0 dimensional solid. Let us draw that figure. X, Y, Z, that portion is A, that portion will be B, that portion will be C. Means electron is confined in that of 0 dimensional solids, in that of 3D potential box, 0 dimensional solid with 3D potential box. So, thus the particle has no degrees of freedom in its motion, or we say it has in its momentum, and it is localized in all the 3 dimensions. So, discrete energy states are associated with all the 3 directions. Let us the potential be 0 inside that of quantum box, but infinite elsewhere. So, the potential we take as the potential, here we consider the potential. The potential means u as a function of x, y, z is 0, where for 0 less than x less than a, 0 less than y less than b, 0 less than z less than c, here is at infinity otherwise. These are the structural way to analyze the potential sequences. Using that potential sequences, we have to introduce the time independent Schrodinger equation within that of box where the potential is 0. So, what should be the time independent Schrodinger equations in 3 dimensional case? If we consider the time independent Schrodinger equation in 3 dimension, we have del square del x square plus del square del y square plus del square del z square over that of wave function psi x y z is equal to 2me by h cross square psi of x y z. The wave function psi x y z may be written as a product of psi 1, psi 2 and psi 3, where the wave function psi x y z can be written like this: psi 1 x, psi 2 x, psi 3 x, and energy E written like as E1, E2, E3, where E1, E2, E3 are the particle energy along x, y and that of z directions respectively. Let us using this to that of Schrodinger equation, using these terms to that of Schrodinger equation, what we achieve? D square psi 1 of x divided by dx square plus 2m E1 psi 1 x h cross square is equal to 0. In short form, we write it as psi 1 double dash of x plus kx square psi 1 of x is equal to 0, psi 2 of x dx square plus 2m E2 psi 2 of x h cross square is equal to 0, that is psi 2 double dash x plus k y square psi 2 of x, sorry, psi 2 of here y, these terms are y, okay, these terms are y is equal to 0. Then z term psi 3 z d, here also these terms are y, z square plus 2m E3 h cross square psi 3 z is equal to 0, which implies psi 3 double dash of z plus kz square psi 3 of z is equal to 0. These are the 3 equations. In these 3 equations, the constants are written as in the form where the constant kx square is 2m E1 h cross square ky square 2m e2 h cross square kz square 2m e3 h square. Let us use the boundary conditions. The boundary conditions as psi 1 x is equal to 0 at x is equal to 0 and x is equal to a, psi 2 x psi 2 y is equal to 0 at y is equal to 0 and y is equal to b, psi 3 z equal to 0 at z is equal to 0 and z equal to c. Look these regions, psi 1 of x is 0 at x is equal to 0 and x is equal to a. X is equal to 0, x is equal to 0 in that of yz plane, in that of yz plane, in that of yz plane x is equal to 0 and x is equal to a, x is equal to a in that of region. Here psi 1 of x is equal to 0. Again another boundary condition means y is equal to 0 and y is equal to b. Y is equal to 0, where y is equal to 0, y is equal to 0 means in that of xz plane, in that of xz plane, that of xz plane y is equal to 0 and y is equal to b here, y is equal to b here. Again psi 3 of z is equal to 0 and z is equal to 0 and z equal to c, and z is equal to 0 where, in that of xy plane, here in that of xy plane, xy plane z equal to 0, z equal to c. These are the boundary conditions. Now we have to use the normalized condition, normalized solution of these above three equations have normalized solutions, normalized solution of these three equations. Psi 1 x is equal to 2 by under root a sin nx pi x by a, psi 2 of y 2 by root b sin ny pi y by b, and psi 3 of z 2 by under root of c sin nz pi z by c, where kx is equal to nx pi by a, ky is equal to ny pi by b, and kz is equal to nz pi by c. Now the complete eigenfunction for a quantum dot, complete eigenfunction for a quantum dot, for a quantum dot, quantum dot. How to write? Psi of x, y, z is equal to 8 divided by under root of a, b, c, multiplying these three, as we taken psi of x, y, z as psi 1x, psi 2x and psi 3x, 8 by under root of a, b, c, sin nx pi x by a, sin of ny pi y by b, sin of nz pi z by c. Here the principal quantum numbers as nx from 1 to 3, ny from 1 to 3 and nz also from that of 1 to 3. Here are the eigenfunctions and the total energies. Total energies, the net eigenenergy corresponding to that of eigenfunction, net eigenenergy, eigenenergy corresponding to eigenfunction, corresponding to that of eigenfunction is what? That E is equal to E1 plus E2 plus E3. Just putting the values of E1, E2 and E3. Look here. Here kx square is equal to 2m E1 by h cross square. So E1 is equal to kx square h cross square divided by 2m. So in these three terms, taking as common pi square h cross square divided by 2m, and all the values are putted like nx by a whole square plus ny by b whole square plus nz by c whole square. These are the net energy, eigenenergy corresponding to that of eigenfunctions. So with the help of this video lecture, we understand a basics towards quantum dots, how it is very important in case of nanoparticles, nanophysics, and a wide varieties of applications in various fields. These are some examples related to the quantum dots and a mathematical approach to quantum dots. The wave function, energy, boundary conditions are put it. So normalized the solution and complete eigenfunction, net energy eigenvalue corresponding to that of eigenfunction. So with this useful and informative notes, let me wind up this session. Thank you.